Well, welcome back. Actually, I wasn't really sure you'd come back from that last video, but I'm glad you did. So let's go ahead and jump into the pointers to structure. Now, this video, relative to a lot of the other videos I do, probably is a little on the shorter side, but that's okay. I really only want to talk about pointers to structures in this video. That way, if you don't understand it right from the get-go, it's not hard to go back and take a look at it and make sure you understand what's going on so you can watch this video multiple times. Now, let's take a little bit of a moment to talk about pointers. It's been a little bit since we've talked about them. So let's do that again. So remember, when we set up a variable that's a pointer, and let's call this PTR. What we're doing is we're setting up a spot in memory that will do nothing more than hold an address. And this address is meant to point to somewhere in memory to something. Now, what can that something be? Well, a lot of times in the past so far, for us, what it has been is a pointer to array. So what we do is we point to this beginning spot in the array, and then from there, the pointer can iterate to each version or each spot in the array, because all these arrays spots are the same size. So it knows to take 0 as the pointer OX123 plus 0 is the very first spot. And then if we say OX123 plus 1, and remember what I'm saying here is this is the indexer, right? So now we know, and we know that this array, let's say it's an array of ints, we know to get to the next spot, we're going to go 1 int size to the next spot in memory, and then that's spot number 1. And then if we do a 2, same thing, starting from here, 1, 2, and that's how we know here. So right now, that's what we've been dealing with. But remember, your pointer whatever that address might be, is pointing to something. Maybe it's just an int. Maybe it's a struct. We can do structs. We can point to structures. So let's talk a little bit about that and see if that makes sense. So, a structure variable has an address, which makes sense because now we're talking about pointers. And the pointer to structures are variables that can hold the address of a structure. And again, we've used this in the past. It should not be anything super new. That star notation. And that tells us that this variable is a pointer. It's not the actual variable itself. It's not the actual item. It's a pointer to that item. And we can go backwards. We can say, you know what? Take the address of this and put it in here by using the ampersand sign. And you can have a function that wants a pointer to a structure rather than the structure itself as well. Now, I know you're saying, okay, Professor Waits, that's good and all, but if the variable is a pointer, how do we get to the members within inside that struct? I'm glad you asked. On this slide, what we're going to see is this not so common way of doing it. Now, you will see it happen. You'll see people do it this way. Usually they'll have a good reason to do it that way, is they're trying to demonstrate something, or they're trying to make sure you understand that this is a pointer to something. They'll have their reason, but you won't see this that often. But what's happening here is we're saying, hey, don't use the pointer per se in this variable. Go ahead and dereference it. So this is what we call dereference. And by dereferencing it, and do that first, that's why I have the parentheses out here. Do that first. So now we are actually talking about the object itself And now we can do the dot student ID. So that's known as dereferencing. And like I said, you won't see it often, but you will on occasion see it. However, the pointer operator, much easier to use. And you will see that most often. Now, the pointer operator, which is what we've got here, is nothing more than a dash with the greater than sign. You know, it's a neat way of making an arrow. So whenever you see the arrow or the dash less than sign, greater than sign, you know what's happening is we are talking about something that's within side of this. It's a member of this, right? And so in this case, what we're saying is, hey, please give me access straight to the student ID that this struct pointer stands for. Now get familiar with this again, just to reiterate, dash greater than sign. So I know you all are going, man, if only I could see an example of that. So let's do that. So this right away, we're talking about a function that's asking for a pointer to the struct type of student. And because it's a pointer, we can use this pointer notation all over the place. And there you go. Now, yes, at any given one of these, they could have said star S. We got to put the parentheses around it. So we do this first. We're going to go ahead and dereference first, and then we can say dot name. Or again, like I said, we really could just make it a little easier and go with that notation. So remember, when it comes to pointers, the variable itself holds an address. Out to something. And in this case, it's a struct of type student. Oh, yeah. Gotta love when the computer's lagging a little bit. Well, there you go. It's not wanting even to erase. Okay. Well, luckily, we're at the end of this video. And as you can see, the computer has decided to stop responding. Hopefully, the audio still is. And with that, I'm going to let you go. The very next and last video, we're going to talk about enumerations and the enumerated data type. It's actually pretty cool, and it's used a lot when it comes to C++. So I'll see you on that next video.